Today we are going to discuss page replacement algorithm optimal. In our previous video we have discussed previous two page replacement algorithm, that is FIFO and LRU. Today we are going to discuss page replacement algorithm, that is optimal page replacement algorithm. So before we start with the page replacement optimal algorithm, we must see what is the definition of optimal page replacement algorithm. Replace the page that will not be used for longest period of time. It means I should replace the particular page which may not be necessary in near future. Before we understand the optimal algorithm in details, we should see the page references referred by CPU, that is 701203 up to 1. These are the pages which are belonging to a particular process. Let's say process P1 I want to execute now, and for process execution of process P1 I need all the pages to be brought to main memory. Total P1 process along with those pages are stored in virtual memory. For the execution of process P1, CPU need all the pages to be present in the main memory. Now main memory is shown here with the help of 3 frames. Let us assume for accommodating process P1 in main memory, we have only 3 free frames available, not more than 3. The real life scenario is, it is not like we will always have 3 frames available in main memory. Main memory may have more number of frames to accommodate process P1. It may have less number of frames also available. For the simplicity and better understanding, we have taken just 3 memory frames available to accommodate the process. So among those references, only 3 references at a time we can store in frame of the main memory. So first CPU is referencing for page 7. So page 7 should be first checked whether it is present in main memory or not. If it is not present, then page 7 should be brought from virtual memory to main memory. So at the beginning, when we are just starting the replacement algorithm, we can see all 3 frames are free. So no frames are occupied with any pages of P1. So when CPU is referencing for page 7, it has to be brought from virtual memory to main memory. When one page is not available in main memory and has to be brought from virtual memory to main memory is called page fault. Why fault? Because it should be present in main memory but not present, so it is considered as a fault. And for that fault, to remove that fault, we need to bring the page referred by CPU from virtual memory to main memory. So what will happen? Frame 1 should be occupied with page number 7. So the situation will be same frame we have drawn once again, but this is the scenario when page 7 is brought from virtual memory to main memory. So it is first page fault for not having page 7 is in main memory. Second page reference is for page number 0, which is not present in any of the frame. So there is second page fault for page 0 because it is not present in main memory, and as the frame 1 is already occupied by page 7, so frame 2 will be occupied by 0. See, don't get confused that we are writing the same frame again and again, we are drawing. This is the 3 free frames. After we brought 7 to main memory, first frame is occupied by page 7. After we brought page 0 to main memory, second frame is occupied. So this is nothing but the replica of the same 3 frames, where initially it was not occupied by any pages, then it is occupied by 7, then it is occupied by 7 and 0, and At the third, when the reference 1 came, all 3 frames will be occupied by 7, 0 and 1 respectively. So now no free frames, all 3 frames are occupied by 7, 0 and 1 respectively. Next page reference by CPU is 2. Now 2 should replace 1 among these 3 because there is no free frame available, all 3 are occupied by 7, 0 and 1. So 2 should take the place of 7, 0 or 1. Which one will be replaced? Now that is the question, and that will be solved by the optimal page replacement algorithm. See here, replace the page that will not be used for longest period of time. It is referencing the future reference of page. Let us solve the issue very simple way. See, 2 is the page which is needed. So 1 among 701 should be replaced. Which one will be replaced? Now, which one will not be used in near future? So let us consider 7. When 7 will be used? See, 7 will be used here. We can do one thing. We can just highlight 7. See, 7 will be used here, whereas 0 will be used in very near future. Where 1 will be used somewhere here. So which one will be used in near future? 0 will be used in near future. Next, which one will be used? Next, future 1 will be used. So which one will be used after a longest period of time? That is 7. So 7 will be used after a longest period of time. So what will happen is 7 will be replaced. We can easily understand. See here, 0 will be used in near future. After that longest period of time, 1 will be used. Next, highest longest period of time, which one is going to be used? That is 7. So in this optimal page replacement algorithm, we will consider the present frame scenario, which are the pages. We will keep on searching those pages. Which one will be used after a longest period of time? That will be replaced. So 7 will be replaced. 2 will take the place of 7. Next reference is for 0. 0 is already present there, so we know there will not be any page fault because 0 is already present. So to avoid any confusion, for 0, no page fault will occur. So there will not be any page fault. It is a hit case. We have already discussed what is hit. So we will just, for simplicity, we will be copying the same frames once again for the reference of 0. Why? Because 0 was already present. So there is no page replacement required. Next page reference is coming for 3. So in the case of 3, 1 among 2, 0 and 1 will be replaced. Which one will be replaced? See here, 2 when 2 is used here. Where 0 will be used in future here. Where 1 will be used here. So first occurrence of 0 is here. First occurrence of 2 is here. First occurrence of 1 is here. It means in nearest future 0 will be used. Next to that 2 will be used, and next to that 1 will be used. So 1 will not be used for a longer period of time. So what we can say is 1 is the page which will be replaced by 3. Okay. To avoid the confusion, we'll place the previous things what we wrote so that we can write it once again if it is needed in future. So we can see next reference coming is for 0. So 0 is already present, so no page replacement, no page fault. It is a hit case. Hit case means the page we need is already present in the memory. So it is a hit. In the case of hit, we will be just replicating the frame. So no change in the frame. Next reference is for page number 4, which is not present. So it is a miss, that is page fault. 4 should be brought to the memory and should be replaced. Should replace one among this 3. So which one will be replaced? Where is the, consider 2, 0 and 3. See, 2 is used here. So 2 is used here. 0 will be used after some time of 2 and 3 will be used after some time of 0. So which one will be referred first? 2 will be referred first. Next 0 will be referred. So 0 is the second reference. Then 3 will be referenced. So then 3 will be referenced. So in longest, after longest time, which one will be referenced? That is nothing but 3. So 3 should be taken for replacement. So 4 will replace 3. Now next reference is for page 2. When the reference is for page 2, what we can see is, we will first remove this. What we can see here is 2 is already present in the, is already present here. So as 2 is present, there is no page fault. So we will be replicating the same value once again. 243, so 243. See, this was a miss case because here 4 is replaced. But this is the case of hit. Hit means 2 is already present. So no change in the frame. It will remain as it is without any replacement. Next referenced page is 3. 3 is also present. So this is a hit. When you will be referencing 3, 3 is already present. So it is a hit. So we'll be keep repeating the same value once again. Now next reference is coming for 0. Among 2, 4 and 3, 1 has to be replaced, which will not be used in longer future. So again we will analyze, we'll take a pen and we will see among 2, 3 and 4, which one is going to be referred in near future? That is 3. Next to 3, 2 will be referred. And see, near future, I don't have 4 here. So first, which one will be referred in near future? That is 3. After 3, which one will be referred? That is second. Which one will be referred? That is 2. But 4 will not be referred in near future. So obviously 4 is the victim page. 4 has to be replaced. So 0 will take the place of 4. Now next reference is coming for which page number? See here. So we'll be keep repeating this 2. We keep repeating this 2 because there was no page fault for pre-arrival and there is no page fault for arrival of next reference 2. So we'll be keep repeating the same value and next our page reference is 1. 1 is not present, so there will be a page fault. 1 among this will be replaced. Which one will be replaced? You can see here in near future which one is used. The 2 is used in near future, 0 is used in after that, 3 is not used in near future. So 3 will be the victim page which will be replaced by 1. So 1 will take the place of 3. Next reference is for 2. 2 is already present, so it is a hit case. There will not be any change in the frame. It will remain as it is. Next reference is for 0. 0 is already present, so no change in frame. Will repeat the same frame. It is also a hit case. Next reference is for page 1. Page 1 is also present, so this is also a hit. It means the page required is already present in the memory. But in the next case, we can see that the referenced page is 7, which is not present here. So this will be a page fault and 1 among that should be replaced. Which one will be replaced is clearly seen here. See here 0 and 1 is referenced in near future, but 2 is not referenced in near future. So 2 should be replaced by 7. 7 will take the place of 2. And next reference is 0, which is already present. So it is a hit case. Hit means we'll just repeat the same frame. 1 is the last reference coming here. 1 is already present. So this is also a hit case. So we'll repeat the same frame once again. So this is a hit. Here also we can see this is a hit. Better we should mention where we have got hit. See, wherever you will see the same thing getting repeated, second one will be treated as a hit. Because there it is a miss. You can see the changes from this frame to this frame. So this is a miss. Here miss is because 2 was not present. But in this case it is hit because 0 was referenced and 0 was present. So we have repeated the same frame. This frame is repeated once again. So this is a case of hit. Okay. Similarly, we can find these 2 frames. So second one will take as hit. Here, see, 3 times it is repeated. So once if everything is clear for writing hit, only we need to check where the same value is repeated. Here, whatever value is there, second place same value is repeated. So this is a hit. Third time same value is repeated. So this is also a hit. Next hit is this 2. You can see here same value is repeated 3 times. So second 2 will be treated as hit. Similarly, here 3 hits. Similarly, here 2 hit. Remaining all are the case of miss. So M denotes page fault or miss. H denotes no page fault or hit. Usually in competitive exam, they will be asking what is hit ratio. Hit ratio is nothing but number of hit divided by total number of page references. We can see here total number of page references are 20, and so always denominator will be 20, and here numerator will be hit, number of hit. How many number of hit we are getting here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be 10 by 20. Similarly, if you want to calculate number of miss, it will, or miss ratio. So miss ratio will be equals to number of miss divided by total number of page references. So number of miss is nothing but total number of page references minus total number of hit. So as total number of hit are 10, total page references are 20. So 20 minus 10 equals to 10. So total number of miss is 10. So miss ratio also will be 10 by 20. Hope you all have understood the concept. Thanks for having patience. If you like the video, please subscribe the video. Thank you so much for watching.